First problem is dive grad r power m is equal to m into m plus 1 into r power m minus 2 or del square of r power m equal to m into m plus 1 into r power m minus 2 or replace m equal to n. Here first we can take grad r power m. What is the r vector? Let r vector is equal to xi plus yj plus zk. Modulus of r vector equal to scalar point function, that is under root of x square plus y square plus z square. Squaring on both sides, r square equal to x square plus y square plus z square. Differentiating with respect to x, y, z partially. Then r square derivative is 2r, r derivative is dou r by dou x equal to 2x. From that 2 get cancelled. Dou r by dou x equal to x by r. Similarly, dou r by dou y equal to y by r. Dou r by dou z is equal to z by r. Here, first we can prove that del square r power m. First of all, calculate del of r power m is nothing but grad r power m equal to I dou by dou x plus j dou by dou y plus k dou by dou z into r power m. Here del r power m is equal to grad r power m equal to I dou by dou x of r power m plus j dou by dou y of r power m plus k dou by dou z of r power m. It is equal to I r power m differentiation with respect to x m r power m minus 1. Again r differentiation dou r by dou x plus j m r power m minus 1 dou r by dou y plus k into m r power m minus 1 dou r by dou z. In all, we can substitute dou r by dou x, dou r by dou y, dou r by dou z. M r power m minus 1 is common from all the terms, taking common. I into x by r plus j into y by r plus k into z by r. This denominator r is also common, that is m r power m minus 1 into xi plus yj plus zk. It is equal to m r power m minus 2 into xi plus yj plus zk. This is grad r power m is equal to del r power m equal to m r power m minus 2 into xi plus yj plus zk. Next, we can find out the div of grad r power m, that is equal to del dot of del r power m is equal to del square r power m, that is equal to I dou by dou x plus j dou by dou y plus k dou by dou z dot m r power m minus 2 into xi plus yj plus zk. It is equal to m is a constant, not r power m minus 2 is a constant. If you think over it is also constant means you get the mistake. But r is also function of x, y, z. You should remember that one. I dot I equal to 1. So m is common from the all terms. That is a constant right outside. The next dot product of I dot I equal to 1, then it is dou by dou x of r power m minus 2 into x plus j dot j equal to 1 dou by of r power m minus 2 into y plus k dot k equal to 1 dou by dou z of r power m minus 2 into z. We know that I dot j equal to j dot k equal to k dot I equal to 0. I dot I equal to j dot j equal to k dot k equal to 1. Next, it is in the form of uv equal to m into dou by dou x of r power m minus 2 is m minus 2 into r power m minus 3. Again, r differentiation dou r by dou x into x plus x differentiation is 1, that is r power m minus 2. In the similar way, the remaining terms also we are getting m minus 2 into r power m minus 2 y dou r by dou y plus r power m minus 2 plus m minus 2 into r power m minus 3 z dou r by dou z plus r power m minus 2 equal to m minus 2 is also common, r power m minus 3 common for the dou r by dou x, dou r by dou y, dou r by dou z terms. The remaining of x by r into x plus y by r into y plus z by r into z. Okay, next r power m minus 2, r power m minus 2, r power m minus 2. That is m into 3 into r power m minus 2 equal to m into m minus 2. Here r power m minus 3 is common. R power m minus 3, x into x, x square plus y square plus z square by r plus 3m r power m minus 2 equal to this x square plus y square plus z square is nothing but r square. M into m minus 2 into r power m minus 3 into r square by r plus 3m r power m minus 2. 1 r cancel. And here 1 is there, minus 3 plus 1 is minus 2. So m r power m minus 2 is common. M minus 2 plus 3 equal to m into m plus 1 into r power m minus 2 equal to RHS. Therefore, div of grad r power m is equal to del square r power m equal to m into m plus 1 into r power m minus 2. This is the solution. Show that del square of f of r is equal to d square f by dr square plus 2 by r df by dr equal to f double dash of r plus 2 by r f dash of r. We can show that here r is equal to modulus of r vector. In the same way, what I explained in the before problem, that is let r vector equal to xi plus yj plus zk. In the question, if r scalar function is there, then you can take the scalar vector point function. From that only we are getting r square equal to x square plus y square plus z square. That is nothing but modulus of r vector square. Okay. From this, you can do the in the examination dou r by dou x, how you are getting x by r dou r by dou y is equal to y by r, dou r by dou z equal to z by r. It should, you can do in that. Without doing this, you can't get this problem. Okay, the right hand side. Here also, in the previous problem, that is r power n, here f of r. Del square of f of r is nothing but del dot del of f of r. It is equal to div dot grad f of r. First, we can find out the grad f of r or del of f of r. It is equal to I dou by dou x. Summation I am taking. Sigma I dou by dou x of f of r. It is equal to summation I dou by dou x of f of r. Differentiation is f dash of r. Again r differentiation is dou r by dou x. Okay. This is here we are taking, it's not d, it's dou only. Dou square f by dou r square, dou square f by dou r, not d. Or if it is with respect to r means dr also, it's no worries about that. Why? Because we are derivating with respect to r. Again, r is differentiating with respect to x. Okay, this is either they have given either in d, it's okay. Why? Because r is a variable. R is treating as a variable, but R is the function of x, y, z. You should remember that. It is equal to sigma I f dash of r. Dou r by dou x is nothing but x by r. From this, we can write it as f dash of r is common from the all terms xi plus yj plus zk whole by r. This is the grad of f of r or del of f of r. Did you understand?
Yes, ma'am.
This summation is expanded for j and k also. We are getting the same term xi by r, yj by r, zk by r. So in between of the terms sum. Next we can take del of f of r. That is nothing but del square of f of r. This is equal to del dot means sigma I dot dou by dou x of f dash of r xi plus yj plus zk by r equal to summation I dot I equal to 1. That is nothing but dou by dou x of f dash of r into x by r. It is equal to, this is in the form of u by v as well as uv form. Okay. U by v means v into summation. V is r dou by dou x of f dash of r into x minus u into f dash of r into x into v derivative dou r by dou x by r square. It is equal to, write separate term to r square, that is r by r square, derivative of f dash of r into x. F dash of r derivative is f double dash of r. Again, r derivative is dou r by dou x. V is as it is. Plus f dash of r dou x by dou x is 1. Minus here f dash of r by r square into x into dou r by dou x is x by r. This is for summation, whole for summation. Okay. 1r get cancelled. It is equal to sigma f dash of r by r into dou r by dou x is x by r into x plus 1 by r f dash of r minus f dash of r by r into r square into r is r cube, x into x, x square. It is equal to sigma f double dash of r by r square into x square minus, plus 1 by r f dash of r minus f dash of r by r cube into x square. Now we can expand these terms for yz also. F double dash of r by r square, x square summation means we can write it as x square plus y square plus z square. And in the 3 in x, y, z, this is same term, that is 3 by r f dash of r minus f dash of r by r cube, again summation of x square, that is x square plus y square plus z square. It is equal to f double dash of r by r square. In the place of x square plus y square plus z square is nothing but r square plus 3 by r f dash of r minus f dash of r by r cube into again x square plus y square plus z square equal to r square. R square cube get cancelled. Here r square get cancelled. It is equal to f double dash of r 3 by r minus 1 by r. In those two terms, f dash of r is common. 3 by r minus 1 by r is nothing but this is 2 by r. It is equal to RHS. Therefore, del square of f of r is equal to f double dash of r plus 2 by r into f dash of r.
Grad different.
Grad is nothing but del only. Del scalar.
Diver.
Diver grad different. Prasadji. Prasadji. అది పెద్ద కుక్కర్ పెట్టమన్నా రైస్ ని రైస్ ని కుక్కర్ పెట్టు టైం నేను చేస్తాను సోగా
Yes, ma'am.
third one. Prove that curl pi A vector is equal to grad pi cross A vector plus pi curl A vector. Here, curl pi A vector equal to del cross of pi A vector. That is equal to sigma I cross dou by dou x of pi A vector. Pi is a scalar point function. A vector is a vector point function. That is sigma I cross UV form dou pi by dou x into A vector plus pi dou A vector by dou x. It is equal to sigma I cross dou pi by dou x into A vector. It's I cross of dou pi by dou x A vector plus sigma I cross of pi into dou A vector by dou x. Okay, is it clear?
Yes, ma'am.
Now, here, just to you think over, this dou pi by dou x is a scalar function. It is not. Okay, pi is differentiating with respect to x, but A is a vector. So cross product we can take for vector only. It is treating as a constant. So this is summation dou pi by dou x into I cross A vector. Okay.
Yes, ma'am.
Or simply we can take it as sigma. It is a constant. Constant is multiplied with dou pi by dou x cross A vector. Why? Because suppose xi plus ai plus bj plus ck is there, multiply with any function means each and every one is multiple with dou pi by dou x plus sigma. Pi is a constant, then that is a function, that is nothing but it is a scalar function, it is not vector. So I cross dou A vector by dou x. This is nothing but grad pi cross A vector plus this is nothing but curl A vector into pi. Div of A vector cross B vector is equal to B dot curl A vector minus A vector dot curl B vector. Here div A vector cross B vector means we can take it as div of A vector cross B vector is equal to del dot A vector cross B vector, that is equal to sigma I dot dou by dou x of A vector cross B vector. It is equal to I dot U cross V. In this, don't change the order. Dou A vector by dou x cross B vector plus A vector cross dou B vector by dou x. Write separately. Okay. Sigma I dot dou A vector by dou x cross B vector plus sigma A vector cross I dot A vector cross dou B vector by dou X. Okay. Change the dot and cross products. We can interchange. It's no worries. First we can do the cross product, then the dot product. In that way. Div of A vector cross B vector is equal to sigma I cross dou A vector by interchange the dot and cross products. Dot B vector plus sigma I cross dou A vector dot dou B vector by dou X. Or simply here we can write it as sigma I dot dou A vector by dou X cross B vector plus interchange the cross products means here we can take minus of I dot dou B vector by dou X cross A vector. Okay, we know that A cross B vector is equal to minus B vector cross A vector, like that. Here, now then we can interchange. Then we can interchange means it should be minus sigma I cross dou B vector by dou X dot A vector. It is equal to sigma, interchange the brackets. I cross dou A vector by dou X dot B vector minus sigma I cross dou B vector by dou X dot A vector. I cross dou A vector by dou X means it is curl A vector dot B vector minus curl B vector dot A vector. We know that A dot B equal to B dot A. In this, no negative signs. Both dot products are same only. So, div of A vector cross B vector is equal to, we can write it as curl A vector dot B vector or B vector dot curl A vector minus A vector dot curl B vector. Our wish. No change on this. Curl A vector dot B vector minus curl B vector dot A vector. First, we can follow the question. How we are getting. Curl A vector means I cross dou A vector by dou X. For that case, we can interchange the products, dot and cross products. Then we can get the solution. Next, fifth one. Prove that curl grad pi equal to 0. Grad pi is nothing but I dou pi by dou X plus J dou pi by dou Y plus K dou pi by dou Z. It is del pi. Curl grad pi is nothing but del cross of del pi equal to determinant I, J, K, dou by dou X, dou by dou Y, dou by dou Z, dou pi by dou X, dou pi by dou Y, dou pi by dou Z. It is equal to I into dou square pi by dou Y dou Z minus dou square pi by dou Z dou Y minus J into dou square pi by dou x dou z minus dou square pi by dou x dou z or dou z dou x plus k into dou square pi by dou x dou y minus dou square pi by dou y dou x. We know that dou square pi by dou x dou y is equal to dou square pi by dou y dou x. Similarly, dou square pi by dou y dou z equal to dou square pi by dou z dou y. Dou square pi by dou z dou x equal to dou square pi by dou x dou z. First, differentiating the order is changed, then we will get the same functions only. So it should be 0. Therefore, curl of grad pi is equal to 0 or del cross of del pi equal to 0. Sixth one is div of curl f vector equal to 0. Let f vector equal to f1i plus f2j plus f3k. Curl f vector equal to del cross f vector equal to determinant I, j, k, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. It is equal to I into dou f3 by dou y minus dou f2 by dou z minus j into dou f3 by dou x minus dou f1 by dou z plus k into dou f2 by dou x minus dou f1 by dou y. Div of curl f vector equal to del dot of del cross f vector. It is equal to I dot dou by dou x of del cross f vector plus j dot dou by dou y of del cross f vector plus k dot dou by dou z of del cross f vector. This is the del cross f vector. Here I dot I equal to 1, that is div of curl f vector is equal to I dot I equal to 1, we are getting dou by dou x of dou f3 by dou y minus dou f2 by dou z plus dou by dou y of, here minus is there, in del cross f vector minus is there, minus into plus minus j dot j equal to 1 dou by dou y of dou f3 by dou x minus dou f1 by dou z plus k dot k equal to 1 dou by dou z of dou f2 by dou x minus dou f1 by dou y. It is del dot del cross f vector is equal to, or div curl f vector equal to dou square f3 by dou x dou y minus dou square f2 by dou x dou z minus dou square f3 by dou y dou x plus dou square f1 by dou y dou z plus dou square f2 by dou z dou x minus dou square f1 by dou z dou y. Here dou square f3, dou x dou y dou x, both are same. Dou square f2, dou z dou x, dou z, dou x, dou z, both are same, but negative signs. These two are both are same with negative sign, it is 0. Therefore, div of curl f vector or del dot of del cross f vector equal to 0. If f and g are two scalar point functions, prove that div of f del g is equal to f del square g plus del f dot del g. Okay. Here, del g is nothing but I dou g by dou x plus j dou g by dou y plus k dou g by dou z. Multiply with f del g is equal to I f vector f into dou g by dou x plus j f into dou g by dou y plus k f into dou g by dou z. Here, div of f del g, scalar point functions only, this del dot of f del g, it is equal to I dou by dou x plus j dou by dou y plus k dou by dou z dot I f dou g by dou x plus j f dou g by dou y plus k f dou g by dou z. I dot I equal to 1 dou by dou x of f dou g by dou x plus dou by dou y of f dou g by dou y plus dou by dou z of f dou g by dou z. Why? Because I dot I equal to j dot j equal to k dot k equal to 1, I dot j equal to j dot k equal to k dot I equal to 0. Now it is in UV. Why? Because f and g both are scalar point functions. Dou f by dou x into dou g by dou x plus f into dou square g by dou x square plus dou f by dou y into dou g by dou y plus f into dou square g by dou y square plus dou f by dou z into dou g by dou z plus f into dou square g by dou z square. Here these terms are right at a time, that is dou f by dou x into dou g by dou x plus dou f by dou y into dou g by dou y plus dou f by dou z into dou g by dou z plus f is taking common dou square g by dou x square plus dou square g by dou y square plus dou square g by dou z square. Here just we can check it as what is the value of del f dot del g and del square g. Here del f dot del g means I dou f by dou x plus j dou f by dou y plus k dou f by dou z dot I dou g by dou x plus j dou g by dou y plus k dou g by dou z. I dot I equal to 1. So dou f by dou x dou g by dou x plus dou f by dou y dou g by dou y plus dou f by dou z dou g by dou z. Next, del square g means del dot of del g, that is I dou by dou x plus j dou by dou y plus k dou by dou z dot I dou g by dou x plus j dou g by dou y plus k dou g by dou z. The dot product dou square g by dou x square plus dou square g by dou y square plus dou square g by dou z square. So it is nothing but del f dot del g plus f del square g. Therefore, div of f del g is equal to f del square g plus del f dot del g, or del f dot del g plus f del square g. Del cross of del cross a vector equal to del of del dot a vector minus del square a vector. In intermediate, one formula is there, a cross of b cross c vectors equal to a dot c into b minus a dot b into c. These are vectors. See, in the place of it is equal to b is del of del dot a vector minus a and b are dels, del dot del is del square a vector. How we are getting means the LHS is del cross of del cross a vector is equal to summation I cross dou by dou x of del cross a vector. Okay, it is equal to summation I cross dou by dou x of I cross dou a vector by dou x plus j cross dou a vector by dou y plus k cross dou a vector by dou z. It is equal to summation I cross O multiply. It is also in derivative of u cross v or a cross b part. The first one is I derivative with respect to x. It's 0. 0 into dou a vector by dou x is 0. Okay. It's I cross dou a vector by dou x is differentiating with respect to x. That is dou square a vector by dou x square. Okay. Its the first term will be 0. When a cross b differentiation means, that is d by dx means dA vector by dx cross b vector plus a cross db vector by dx. But in this, I means it's eliminated. So we are getting the second one only. Further three terms plus j derivative is 0. The first term is eliminated. J cross dou square a vector by dou y, dou x dou y plus k cross dou square a vector by dou x dou z. Okay, this is the differentiation of this. It is equal to sigma I cross of I cross dou square a vector by dou x square plus sigma I cross of j cross dou square a vector by dou x dou y plus sigma I cross k cross dou square a vector by dou x dou z. Okay. In this, it is a cross b cross c. We can written as sigma a dot c. That is I dot dou square a vector by dou x square into I minus, it is a dot c into b minus a dot b. I dot I into dou square a vector by dou x square. Similar way, plus I dot dou square a vector by dou x dou y into j plus I dot j equal to 0. Next, I dot dou square a vector by dou x dou z into k plus I dot k equal to 0. That is minus terms are eliminated in this. Here I dot I equal to 1, I dot j is 0, I dot k is 0. So it is equal to sigma I dot dou square a vector by dou x square into I minus dou square a vector by dou x square plus I dot dou square a vector by dou x dou y into j plus I dot dou square a vector by dou x dou z into k. Here we can write it as 1 dou by dou x is for left I, 1 dou by dou x is for right I. Then it is nothing but del of del dot a vector. It is equal to sigma I dot dou a vector by dou x, I dou by dou x minus this is del square a vector. The same way I dot dou a vector by dou x, j dou by dou y plus I dot dou a vector by dou x, k dou by dou z minus summation dou square a vector by dou x square. This is equal to del dot a vector. This is del dot a vector. Common in all, the remaining terms are I dou by dou x plus j dou by dou y plus k dou by dou z minus this is expansion is del square a vector. It is equal to del of del dot a vector minus del square a vector. Is the answer. Therefore, del cross of del cross a vector is equal to del of del dot a vector minus del square a vector. This is somewhat difficult, just you can keep on mind this formula a cross of b cross c equal to a dot c into b minus a dot b into c. Here the main thing is this distribution is little bit difficult. If you get that one, then you get the right hand side.